on worksheet number 1, then you press graph, which is in the top right, and that brings you to table, and you can see here that now you have a table of values which you can now write down. So I would recommend that you go ahead and write them down. That should be your first and second step. You can see the errors just means that you can't use those values, so we start at 1. Okay, so we have some values there. Okay, does anyone know what we do next? What do we do next here? Jude? Right, we graph it. We just plot the points. So hopefully your graph looks something like this. Should just plot the graph and kind of estimate it. Should look something like this. So if you want to write instructions here, you would just say, first step is to type your equation into your calculator, into the y equals. Second thing you can do is go to your table by pressing second graph, and you can write down the table of values. And then third thing is you're going to go ahead and graph your points that you have found. Okay. Log? Oh, how did I put it in? So for this problem specifically, I typed it in as log 2 of x, comma 4, comma negative 4. If you have an older, say you have a TI-83, you actually have to type it in like this. You have to do log 2 of x, parentheses, divided by log of 4, then you do minus 4. So if you have an older version, so TI-83, you actually have to type it in like that. It's not as nice, but accomplishes the same thing. Okay. So that's only if you have a TI-83 or older, then you have to actually type it in the longer way. But luckily for the newer ones, you can actually type it in the first way. Okay, so the next thing we do is we find our domain and range. We have to start answering those questions. So looking at this graph, Daniel, what is our domain here? What is our domain?
It would be 0, infinity.
0, infinity. What makes you say so here?
Because the graph doesn't go further than 0.
Okay.
But then if you go as far as infinity on the other side.
Okay, yeah. So in this one, just as a reminder for log, it has an asymptote starting at x equals 0. And depending if the graph moves right or left, the asymptote will move. But for this graph, you can see that the asymptote does not move at all. Our graph does not move right or left. So the lowest value that we can have for x is 0, but we can have any other positive integer, a real number. And so our domain is 0 to infinity, right? 0 to infinity. So the 3 ways that you can write this is one of the ways Daniel touched on, which is 0, infinity. That's interval notation. You could say x is greater than 0, or you could say 0 is less than x, which is less than infinity. Those are all 3 possible ways to write the domain, right? If you answer in any of those 3 ways, you will get the correct answer. Okay, for range here, Pranav, do you know if you can answer, what is the range for this problem, for number 4? So negative infinity to infinity. Why do you say so? Right, there is no limit to the y values. So since there's no limit to the y values, you could say negative infinity to infinity, like so. So that's interval notation. You could also say negative infinity is less than y, which is less than infinity. Or you could say y is the set of all real numbers. Okay. So any of those three, again, are okay. Right, any of those three are okay. Okay, Garrett, how do we solve for our x and y intercepts? Or what are our x and y intercepts?
Well, there's no line intercept because it can only approach 0 and never actually reach 0.
Okay. So you just write none. What about your x-intercept?
I got 128 and 0.
Okay, how did you get that?
I used the table because it was one.
Or how did you know how to get that?
So it's the same the y equals log 2x, 4, and then minus 4. Extract into the y equals, and then you use the table button and use that, and then you can scroll all the way down to y equals 0.
Dang, you scrolled that far? That's crazy. Okay, you could do that. You could scroll and see where it equals 0. Does anyone know a more, does anyone know the algebraic way to solve for your y-intercept? How do you solve for, or sorry, your x-intercept? What's the algebraic way? Prana? Okay, so the other way is that anytime you have an x-intercept, y is equal to 0. So we can set y equal to 0 and then we can solve. And then do you want to help guide us? How do we solve this? What do we do first? Do you want to lead us, Pranav? Okay, so first we add 4 to both sides. Then you can finish the problem. Not quite. Not quite square root. Remember how to move a log. Does anyone remember, what are we supposed to do at this point? Oh, Gary?
So since the log goes to so the number on the other side of the equation becomes the exponent of the base of the log.
Right, so we can change this to exponential form. You can move this log to the other side, and it becomes 4 to the 4th power equals 2x. And I will quickly calculate. 4 to the 4th power is equal to 4 times 4 times 4 times 4, which is equal to 256. And then we have 256 is equal to 2x. And then divide by 2. And we get x is equal to 128. So your x-intercept is 128, comma 0. You could do this way, or you, as Garrett said, you could scroll down like 128 spaces down or up. But it doesn't guarantee that you're going to find it in time. But I guess if you really have no choice, you could just scroll down if you forget how to solve it. Okay, we're almost done. So this is the x and y intercepts. I will say that for your x and y intercepts, you usually have to solve for them for logarithms. For the other one, it's easier for exponential. Okay, so the last part is as x approaches y approaches, and as x approaches, y approaches. Let's see here. Robbie, could you help us out here? How do we know what our end behavior is for this graph? So we're looking at this graph. How do we know what our end behavior is? Okay, why do you say so?
You can say like as x is approaching negative infinity for lambda, it's approaching, or y is approaching
Okay, why can't we put negative infinity for x? What made you say 0 instead?
because the graph never touches x equals 0,
Right?
so it's always approaching 0.
Right, and so our graph, remember we're trying to see what happens to our graph as we go farther and farther left. What is the farthest reaches? And we know that x never goes past 0, so it's never actually going to equal a negative number, but it will always approach 0, right? It's always going to get closer and closer to 0 and closer. And as that's happening, y, as Robbie's saying, is going to get smaller and smaller, or sorry, well, in a way smaller, but in a way a larger and larger negative number. It's going to just keep exponentially getting bigger. Okay. So we would say as x approaches 0, right, x is getting closer and closer to 0, y is getting like approaching negative infinity. It's getting to a bigger and bigger negative number. Okay. There's no limit to that. Okay, what about the other side? Jody, how do we know what the other side of the end behavior is here? Okay. Okay, so, right, so as x approaches infinity, or it goes towards the positive side, there's no limit to x, y is actually going to slowly increase, although really slowly, it's actually going to increase forever. So there's no limit to each one. As the graph goes more and more right, there's no limitation to where it's going to go. X is going to increase, and y is also going to increase, and then that's one problem. Okay. So that's how we would do kind of like the front page and the second page. This is exactly how you would solve those kind of problems. Okay. Okay.